Okay. And then I go a little bit about what does a job submit script looks like, because the job submit script is the meat and bones of everything you do on our cluster. Even if you don't see it, you still need to know a little bit about the details. So first, this is kind of, I always show this slide. It's just very outdated definition of HPC. It's basically that you aggregate computing power. It's just, instead of just your little desktop, you have a whole cluster, a whole rack of nodes, a whole collection of nodes that you use. And it's especially for large jobs engineering, ocean models, you combine the power of multiple nodes in one. And that's why you have paradigms like MPI, where you can communicate data between processes. But it can also mean multi-threaded. It's basically you have a set of nodes that are large and you utilize them for problems that cannot be solved on a regular desktop. Now, HPC has grown over the years, so this is kind of a little bit old-fashioned, but this is kind of still definition that people use. So what is an HPC job? What does it actually mean? So in general, you do research, you get your data, whatever data it is. This can be samples from a balloon that goes up in the air. This can be surveys that you do among health patients. This can be anything. And then you have a program that analyzes it. That can be a forecasting model. It can be statistics, it can be machine learning. But most of the time, an HPC job follows this paradigm where you have data and you have a program. It's most of the time, because this implies kind of a batch environment where you just have your data, you prepare it, and then you run it, and then you come back when it's done. You have also interactive, which I will, but it follows the same principle. So you set up your data, you have your program, and then you submit it to this large machine, be it Amazon, be it UF, be it here at FSU. It's you don't really see the machines. You might interact with some interface, a command line interface, a graphical interface, but it's you shove it up. You don't really care where it's running. You just want it to run and get results back. And in the end, this board is in front of them. In the end, you get some output, whatever that may be. So in general, this is what people, when they call it, when they have a HPC workflow, this is what they mean. Now you can have a lot more complicated things because the data may come from some instrument that you may have in your lab, and then the data gets transferred through some elaborate way to our systems. But the whole principle of an HPC job is like this. And I should have moved this around. But so what does an HPC, how does it look like? Now, this is a very simplification. So this is a representation of compute nodes. And at the current, in what we have now, it's like we have around 800 nodes. It's like 800 servers. Some of them have 2 CPUs, some of them have 4, some of them have 8 cores, some of them have 64s. They can be Intel, they can be AMD. Some have to have a very limited, although the 16 have been phased out now. But some of the bigger machines have 512 gigabytes. They're all connected with a very fast network. And so it's very heterogeneous. It's not like sometimes you hear that everything is the same, especially the largest centers. All their machines are the same, but we're kind of, every year we add new machines, and that's why it's such a diversity. So we have all these resources, but how do you divide them? How do you allocate them? Because everyone wants as much CPU time as possible, but we don't have that much limit. So if you're not careful, then people start logging into nodes and start to run jobs, and you start interfering with each other. So how do you fairly divide up those resources among users? So I like this thing. This is like an Amazon warehouse, and you should see these packages as compute jobs. So every package has to go through a customer, which is their output of the data. And some of these lines, they are kind of very slow, and some of them at the bottom is like very fast. So this is someone who pays for his Prime membership. He gets, well, it used to be 2 days, but now it's like maybe 2 days delivery of his package. Well, if you're not a Prime member or you don't care, then you can sometimes wait for a week. This is the same thing with a job scheduler. A job scheduler divides up programs to run somewhere on a cluster based on the priority. The priority can be you submitted your job to a free resource, but you have to be waiting in line. Or maybe your professor or your lab bought compute nodes, and then you're in the high priority and your job can maybe start immediately. So you should see job scheduler like this. It just tries to divide up the jobs in a kind of a fair way. Also take some priority in if your job just started, you may have to wait, but if your job is in the queue for a long time, then you might run faster. Or if you have a very large packet, like a very large job, you have to wait for all those resources to become available. Well, if you have a very small package, it might slip into the cracks. There might be somewhere in the line, there's a little space left, and someone can put a little package in there. So for this is a new slide. That's always confusing, the nomenclature of job schedulers. So I picked actually the bottom 3 examples. It's too bad you don't see it. The screen is a little blocked. So in general, you hear 3 different terms. Most people will use queue. When they talk about job schedulers, they talk about queue. And queue is just a very generic term that's used by everyone. And it's basically like a list of running or waiting jobs. If you have a programmed operating system, fortunately, then you may have a run queue or wait queue. The same thing with HPC system, when they say you have to submit it to a queue, that means just basically a generic list of jobs. Now, queue is not specific to Slurm. We use Slurm as a job scheduler, but there are others like Moab. So what we use is the 2 terms partition and account. The partition is just a collection of similar computers. It's if we have GPU nodes, then there's the GPU partition. If there's high memory, you could say the high memory nodes. Now, who can access those nodes is what we call an account. So an account is like an administrative something that says this and this user can submit to these nodes. So usually an account is tied to 1 or more partitions. In our current setup, what we have at RTC, an account is similar, is usually tied to only 1 partition with the same name. So that's why it can be confusing. And so I'd like to show some confusion. I looked at some other system, University of Florida, their documentation, everyone mentions queue when they actually mean account. And in the documentation, they even sometimes swap things around. TEC, which is the Texas Advanced Computing Center, which is a large national center in Austin, Texas. They use queue when they mean partition, and they use project when they mean account. Now, it's part of XSEED, it's part of the National Science Foundation. So in XSEED, you apply for project allocation, so it kind of makes sense. So this is kind of the nomenclature just to make sure. We usually say account when you want to submit a job, because an account is just gives you access to resources. But we sometimes still use account and partition vice versa. And I will show you in some of these slides that even on our website, we still mix that mistake. So how does it look in practical thing? So this is our cluster. This is a set of compute nodes. So we have 3 partitions. We have the high memory nodes, which is the green one. We have our GPU nodes, which is the yellow, and we have our general compute nodes, which are blue. It's actually gray, but okay, I call it blue. Now, the partition is the specific set of nodes. The account gives you access to run on those nodes. That's kind of a clear distinction. So what I said before, currently every account is tied to only 1 partition, but in this example, my account is tied to 2. Ooh, nice. So my accounts use a PAL access to blue and yellow. So we're going to go to this in the future, but that I submit to that account and I can run on both sets of nodes. While this user, Marcelina, I've never heard of her, can only submit to these blue nodes. No, so if you go through our website, you'll see a whole list of accounts. It can be confusing which one to pick. First of all, there's only a few free resources. There's We have a number of free accounts and a number of paid. Most of the time you will have access, everyone has access to the free resources and maybe one or two paid accounts. Now the free, it's even, and I'm not going to go through the whole list because we have several accounts, free accounts, but which account to choose is always the biggest question. In general, we tell people use the general access. General access is just a free resource that runs on 60% or so of our nodes. And it's used a lot. So it may be that you have to wait for 10, 20, 30 minutes for your job to start. In general, I did some testing. It's usually within a minute or two. Now, sometimes you just want to quickly test if your job script works. We have the quick tests, which is just to test if something runs. And then we also have special partitions, special accounts, which is called the backfill and the backfill 2. The backfill run on all our machines, but they have a limit of 4 hours. The backfill 2 is even more restricted. It even runs on the latest machines that we have. But if it runs on owner nodes, but if the owner wants to use its node, your job might be getting killed. So it sounds very risky to submit to the backfill 2. But the nice thing is, if you want to have fast access, it will run. If your program does something like checkpointing, which several programs do, so it basically, if it writes a state every 10 minutes, every 30 minutes, so you can restart, then you can really effectively use the backfill 2 partition, but you have to make sure that you can restart from the stopped experiment. So and then we still have Condor, and Condor is a special case. It's if you run a really long. So I should have put a slide with some overview, but so general access is the most used partition that we have. Well, maybe it's one of the most used, and it's the default wall time is I think 2 weeks, and the maximum wall time is 2 weeks. So if you notice your job will be able to finish in 10 days or in 11, you can use the general access. If you notice your job can finish within 4 hours, or if you can restart the crash job, then you can use the backfill or backfill 2. Now, if you notice your job needs to run in 30 days or 40 days, then we have the Condor partition. Condor partition is a very small subset of nodes, but it allows you to run jobs for up a maximum of 90. Now, the issue is stability too, because if you run on 30 nodes for 90 days, the chance that something happens is likely. Just like we had 2 weeks ago when we had a fire drill and something went really bad and we lost power. So, but still in general, those are the kind of the general access, the backfill 2, and the Condor. Now, if your lab has purchased CPUs, if your professor said, I want to have dedicated access, because sometimes you want to have guaranteed that your job will start. You want to have a guarantee that you're running on the latest nodes. That's when usually people buy into our system. So your professor might buy machines, and then you can have access to that. Now, in general, it might be a lab, but if you're, for example, part of EOS, the whole department chips in and they buy machines. Or if you're part of co-ops, I don't think there's any other departments that buy in, but some larger departments buy in themselves collectively. So the individual professors don't have to buy in. So now this I made a few nice images, GIFs. So how can you, but they keep on rotating. So how can you submit a job to the cluster? Now, first of all, there's the standard, very old-fashioned command line interface. It's SSH, and this is just the Linux things. It's basically I'll log into the machine, I go to the directory that and if you can read this, it's fine. I go to the directory with my job information, and I just run sbatch for a shell. And that's basically it. My job is running, and then hopefully in an hour or 2 or 3, it will continue. So if you want to submit a job to the command line, for all our resources, if you're off campus, you have to use the VPN. It's just, we were hit by so many SSH attacks, whatever you have. We will make the slides available online. If you connect from off campus, you have to use connect to FSU's VPN. It's Cisco. It's very horrible software, AnyConnect, but we have a description on our website what you need to install it. Once you have installed it, it's there and it will be there. So after that, you use SSH. SSH, there are multiple implementations. Depending if you have Windows, you can use Mobile Xterm. If you have a Mac, that's Terminal. If you have Windows, you can also do SSH from, what is it, the PowerShell or whatever they call it, commands. So you SSH to the login node. The basic workflow is you create your job script. If you want to know how to create a file, there's the intro to Linux workshop that we did a few weeks ago, I think. Yes, before the hurricane. And then you use one of these commands like Astron or asbash to submit, and you use asq to check. It's all very straightforward. It looks complicated, but it's just a few commands. And in the past, I did a tutorial of it. I did a small demo, but I'm not going to do that. So, like I said, you prepare your job file, you have your data uploaded to SFTP or whatever SSH commands. So then there's actually 3 commands to run to submit a job. Most people will use asbatch. Asbatch is from Slurm batch. It submits the non-interactive batch command. And what it basically does, it will tell the job scheduler, I want to run this. The job scheduler will give you a job ID that you can use later for whatever to check if things are still running. And you can log out because it's somewhere scheduled, it's somewhere in the system. You made your order in Amazon, somewhere is a package with your name on it, and it will go into the whole machinery, and at one point, hopefully it will drop off at your home address. Now, sometimes you want to run interactively, and that's when there's command like salloc and srun. In the past, I would tell people to use srun, but I've been kind of swifting to salloc because it's slightly more clear what it does. Alloc, basically, it allocates a reservation. So if you ask for like 4 cores, it will try to request for 4 cores on whatever machine, and then it will give you a prompt back, and then you can run whatever commands on that compute allocation. And in this case, maybe I should show a little demo, because xalloc is kind of confusing. So I logged into one of the login nodes. I just use the generic term, and then I say salloc. Now I want 6 cores, and I want it in the backfill too. But what it's doing now, it says pending job allocation. It goes into the system. And this is a live demo, so I hope I picked the right partition. Sometimes it takes a little bit. Otherwise, I'll just pick another one. I should have, of course, picked a quick test, because the quick test is... Let's just do that. So I allocate 6 cores in the quick test account. It says a granted job allocation. It prepares the machines, and now I'm ready. No, I have to, as you can maybe see from the job prompt. I'm not sure if I can increase the font. I'm still logged into the login node. So if I do a who, and I still see everyone on the login nodes. If I want to run something on the compute node, I have to run srun. Everything I want to run, if I have allocation, no, I cannot run R because R is not multiprocessing. You must, I hate R. So here I'm running R, but it's on the compute node. And I'm not sure why it's there. Everything I run with Astron runs on the compute nodes. If I run it like this, so as Alloc can be confusing, but can also be very handy, because everything you run runs on the login node, but if you use Astron, it will run on the compute nodes. Now, why do you want to have interactive? For example, if you're debugging a program. If you're debugging a program, you want to have control of what's happening. It's not a batch. You want to step through your code. And that's, now I have to go back to, if there are questions online that need to be responded, answered. Okay. So as batch, like any Linux commands, the way to figure out all the details about a command is use the manual page, the man page. Slurm did a good job of documenting all the commands. So if there's any commands, then you can just do man whatever sq man as batch, and you get a long confusing list of all options. Now, just to learn the application, it's very confusing. But if you want to know the fine details of what is really the difference between -lowercase n uppercase n, what exactly -man per CPU, man per task, man per core, man per gigabyte, man per thread, what all these options mean, then the man page is the place to be. It's like your encyclopedia. It's just, you already know where Spain is. But if you really want to know the amount of people who live in Barcelona, you just look it up in Wikipedia, but you use it and look it up in an encyclopedia. The man page for Slurm is like that. Most people will just do the next command, which is the wrong parameter. They will use ashbatch -A my queue my account -n and then my script. So this line is like how most people will use Slurm. Now, -n can be 1, or if you don't specify, it will be 1, but this is how most people will do it. So this will request 10 cores on the myQ queue, and they use my script to run it. You can also just use my script, which is the simplest form, which will just, on your default account, will request 1 core and run that script. Now, there are much more complicated things like -d, which I wish I could block this bar below, but I guess not. Now, there's also Astron. You can use Astron to submit the job. Astron is similar to Alloc, that it can be used for interactive processes. So if you use Astron-A my account my program, it will start a program on a compute node, but will give you the output back. It will print everything directly to screen instead of just running it in the background, and will send you the data in the output to screen in a file. So SBatch will run in the background. It will start a job, submit it to the job scheduler, and then return directly to you. Astron will just stay in the foreground and will just like Alloc, it will give you back your control. So if you quickly want to check your MATLAB code, you can use Astron and just do your the simple command version of MATLAB and run it on the compute node. Now, you can give it a script name, but the confusing part in the scripts, it will not interpret any of the ashbat flags that I'll show you later. It will just run what's in that script. That's kind of confusing, but I'll show you later how a script looks like. It's just the Alloc is similar to Astron, but you have to be careful because, like I said, the commands work on the login node, but you have to use Astron to submit it. Astron, as you may see, has multiple goals, and I think the Slurm people should have separated. So you can, if you have a parallel job, you use Astron. If you want to do interactive, you can use Astron. It's multiple things that you can do with Astron, and they're not all the same. And if depending on if you use Astron as interactive or not, it will behave differently. So you have for people who do parallel programming, what you in general you use MPI. What MPI does is if you have a program, you can start it up n times. So let's say if you want to run an MPI program on 10 cores, you want to start that program 10 times, and then you do your MPI initialize and blah, 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 to have a kind of the same namespace. Sometimes you have to use MPI run to do that starting. So MPI run my program, we use Astron my program. If you allocate 10 cores and you use Astron my program, it will start 10 instances of that my program. And then hopefully they will start talking with each other through MPI. Now, why do we tell everyone to use Astron and not MPI run? We don't even provide it anymore, and it's because Astron works much closer with the Slurm job scheduler. It needs to know where to run the jobs. If you ask for 10 cores, they may run on 10 different nodes, or they may run on 4 different nodes. And Astron is better in figuring out where to start your job. It's all the things that you don't really want to care about. You just want to have 10 cores, and it doesn't really matter where they are. You want to make sure that Astron kind of starts it. So Astron in general, if you have a job script, it's basically Astron my program, and it will start on the number of cores that you requested. Now you can also do individual. If you, for example, want more memory, you can lower that. But in general, we tell people not to. I should come with more examples. Now, interactive, if you really want to do interactive, you can use as Alloc and as run. But as run, as Alloc, like I said, it's already showed, you use it, it's interactive by itself. Well, as run, you have to say the --PTY flag. PTY is like this old Unix term for I think physical terminal, or it's so you have to do yes as PTI, and it basically means that Astron should expect inputs from you. So for example, if you want to run R on a compute node, if you want to use the debugger GDB on a compute node, you can use Astron-PTY GDB my program, and it will start an interactive debugging session on a compute node. There's some tricks. There's some little weird things, like I said. Astron can be confusing in the beginning when you start just using it, because if you use Astron-N with a number of cores and then --PTI program, it will start that program on once. If you don't use PTI, it will start it X times. So if for example the command hostname, which just prints the host name, if you Astron-N10 --PTY hostname, it will print the host name of one node. If you don't, then it will print the 10 nodes that you start the job on. Now that kind of makes sense, of course, because you can only have one input. Because if you type on your command line, it can only go to one node instead of 10. So that's why PTY only starts at position 1. So, but it can be, you can do very confusing tricks with Astron when you have So I mentioned a few commands. So this is kind of an overview. I'm not sure if you can see it. No, of course you cannot see it in the room here. We have a cheat sheet on our website with a lot longer list than this. And in the past, we actually had paper copies that we would hand out, but then we went all virtual. And we have a cheat sheet on our wine. It's RCC. I think you can also get through it through our website. Probably documentation. Do you know, Alex, from the top of your head?
No.
Okay. So there's a number of commands that most people will use. There's --batch to submit jobs. There's --run and --alloc if you want to start interactive programs. There's the SQ. SQ is just to show processes running, and it can be your partition, it can be your account, it can be your username. It just shows you everything that's running or waiting. Now, you can also just use SQ to look for a specific job. Although and there's also as control, but that's you need a little bit more privilege. You can also use SQ to see when your job is going to start. So by default, SQ will show all jobs waiting and running. If you do SQ-start, it will only show jobs that are waiting, but it will give you an estimate time. So if you want to know for a specific job when it will start, and say your job, you just submitted it with S-batch, and it gives you back 1252, you can just do SQ-J and then --start, and it will give you an estimate time. Now, it is an estimate because who knows, the person in front of you, his job may crash after an hour and it will not run for 2 weeks. But in general, it's pretty decent estimate of time. Then, of course, there's also as-info, and as-finfo can show you a lot of information about nodes that are in your partitioner account. Now, I didn't mention it, but we have our RCC tool program, which is a tool that we provide. RCC tool can give you a lot of information, including what partitions you have access to, and what all the nodes are that you have access to. So I'm not going to go into RCC tool, but if you have access to the HPC, type in RCC tool. It's not the fastest, but it will give you a long list of options that are available to you. And I think it even allows you to change your password, but I'm not entirely sure about that. It's I think Casey is online and he can maybe give some. Now, this was the kind of the old-fashioned kind of I'm a hardcore guy. I do command line. We have also options to submit job through web browser. If you're not comfortable using SSH, if you want to do something quickly, if you're at a terminal at the airport and you don't want to install PuTTY on that terminal because you're not allowed to, we also use a web browser. Now, the only thing is, like everything, you still have to use a VPN. Now, like I said, that can also be an advantage because the VPN has a web option. You can open a web browser and go to vpn.fsu.edu, and you can have a browser session in that VPN session. So if you're at the airport at a terminal, you can actually submit a job through that. So this Open OnDemand, I'm not going to go too deep into Open OnDemand here because it has a lot of options. And so that's why we're going to have a workshop on Open OnDemand next semester, where we go deeper in all the different options. So there's the traditional way of where you can just set up a job and submit it as a batch job. There's also a component which we call virtual desktop environment, where you can run a graphical program. For example, if you have RStudio, if you have MATLAB, you can run it through our Open OnDemand. Today, I'm only going to show a little bit about, I think if I click this, it will restart. Oh. Of course not. So Open OnDemand, OOD. I wish this would. There's a problem with Google Slides if you have animated GIFs that will kind of either stop after one thing or just keep on running. So OOD, basically, you log into ood.rcc.fsu.edu, and then there's a jobs and job composer. Job composer, if you have set up a template, or you can create templates, it's very easy to say create a new job from a template. You can edit you can edit the job file and then just submit it. And this is the last screen where the job is submitted, and here it says it's cute. It's not cute, it's cute. That's so that is one option where you can just basically go into Open OnDemand, go into the job composer, and then you can create a new job, you can clone an old job. If you run something in the past, you just want to change something, you can say create a job from an existing job, and it will create a new project, whatever they call it. You can add a little bit in the job composer. There's an online editor in Open OnDemand, and then you can submit it. The other option is what I call the virtual desktop, and I will go briefly over this because we're going to do a workshop in the spring about this. So, for example, in this case, I'm just going to show, I decided to give up on the animated GIFs. So here, like I said, there's jobs, clusters, interactive apps. Here I go into the interactive apps. Now this is only a short list, but we're trying to expand this as much as possible. If anyone has an application with graphical interface that they want to have installed here, just send us a ticket to support at FGEDU and we'll look into this. So in this example, I want to run R. I love R. It's a statistical program. It's I don't know really that much about R. I just used it a little bit in the past. So I go into R, I get this template, and that's why I say that it's always important to kind of know. It will give you all this, it fills out some of these fields already. So it will give you what a partition, the number of hours you want your job want to run, number of cores, amount of memory required. It's R, so we have multiple flavors of R, so you can actually pick which version you want. The default is 3.5.2, and I'm not sure what versions we all have installed. I'm not sure 4, but then yeah, so we have 4 too. If you want to, it's not the default yet, but if you want to use 4, then you can use that. So if I, for example, need more hours, because the default is very limited, it's just that we want people to think what to submit. So if you think, oh no, I really need 4 days, you have to change that. And I think you have to actually just do the math and just say 4 times 24. I don't think you can use the Slurm notation, but I'm not sure. I think you actually have to do the math.
In there, yeah.
Yeah. So yes, you have to specify the number of hours. You cannot say in Slurm itself, you can specify days, hours, minutes, but here you have to actually specify the hours. No, there's always to like blink and you miss it. Oops. We still use partition and not accounts. Anyway, so I clicked the submit. I'll get this screen. It's basically like SQ it commands. It will show you that my job is created. And then actually I wanted to make a screenshot after waiting, but it almost immediately started my session. So now it's just, this basically says it's running. So now I click connect. And I get this, I only truncated. So this is RStudio running in a web browser. And RStudio is basically a wrapper around R. So it's not like very fancy, but it's like you have the R interface and you have all the other the environment variables. You have the menus up there. What people are use RStudio. So, and this slide was always one of the first, and I moved it to the last. So I've been mentioning job submission script a lot. Everything you do involves a submit script. Even if you go to a virtual desktop, it's the RStudio, a job submission script is created, but it's still good. Everything works with a submit script. Well, what does it mean? It tells the job scheduler what you want, what to run, because the job scheduler will start your job, it will run your job, so you have to tell it exactly what you want to do. So so like all these commands I showed, like S batch test A blah blah blah, you can put those in the job submission script. So if your professor is called my name is very long and this is my lab Q_Q, you don't want to type that all the time. So you can put that as a parameter in your job submission script. So it saves you on time. For if you always run on 16 cores, you can put that in your job submission script. Now, if you ever want to run on 32, the command line will override whatever you have in your job submission script, but the defaults you can put in your job submission script. Now, if you need a lot of setups, if you want to copy data from some directory, if you want to create a temporary directory, if you want to do some initialization of your code, you set all those steps you put in the body of your script. And that's all those steps are run on the compute on one compute node. It's the same if you use Astron --pty. Your job submission script will only run on one node. Everything you want to do in parallel, you have to start with --run. So Most of these job submission scripts are bash, or if you use TCHA, your TCH shell. But that doesn't stop you from using whatever. As long as you have a language that uses the pound command style, you can use any language. You can use Perl or Python as a job submission script. And almost, I think you can even use R as a job submission script. Now you have to be you can, but. So let's go over a very simple sequential program. So there's three parts of it. First, someone has to know what kind of script this is. So that's why I have the first line bin bash, which is basically this is a bash script. Now the second part is for the job scheduler. Everything you want to tell the job scheduler has to start with pound or hashtag whatever, hashtag batch. So the first one is just capital J is basically this is the name of my script, of my job. So if you ever do SQ, you can see that in the list. It's just first aesthetics. It's not really used for anything. It's just the name of your script. Now in this case, I'm using R in this batch command, and I give it the input R input text. Basically, it copies the lines for the input. But then we have the body. The body is it's basically three commands. First of all, I just print out what my working directory is. Just if I later look at my log files, I can see where I executed this. If I do a lot of experiments, I might not know where I run everything. My file organization might not be as good. This is basically just later to see where I run a command. Or if I have an issue, I want to ask the support people in RCC. They first ask you, well, where's your job script? And you just basically, here it is. The second thing, module load R. We have several versions of programs on our systems. And you can have multiple versions. This basically makes sure that the default R is in your path. That R is by default not in your path, and you have to do module load R to get R in your path. If there's a experimental version 12.2, then there's R/12.2, but I'll go into that later if I have time. And then the final command is R no safe, and then we'll get inputs from the my R input text. The difference between a sequential and a parallel program is very minimal. It's still the same layout. The first line is that bash. Then I still have this my job name. The only difference is there's the dash and 10. So this job will ask for 10 cores instead of 1. Now in the bottom, there's the thing that has to be done. So I want to use OpenMPI in this, and I want to use the GNU version. So I do modulo GNU OpenMPI, which gets all the MPI libraries in my path. Now I still want to know where I'm running this. And then I use srun my program, and srun my program will run my program on 10 different cores. The module load GNU runs on only one machine, but the srun my program will make sure that my program runs on 10 different cores. So this is basically the difference between the sequential and a parallel. There's almost no difference. It's just that I ask for more cores. Now, do you need to use srun all the time? No. For example, if you have a multi-threaded Python program, and you can ask for more cores, you just have to make sure you run on the same node. But then it's just, you can just use the Python command, and whatever Python module you have for parallel programming, it will start on those 10 threads. Anyway, so this is something weird. So I told that you can use any programming language that has the hashtag as a comment. This is one of those things. So this is a Python script. Now, most people just use the direct path to Python. I used to like the env and then Python 3. So it can pick up any Python 3 that you want if you want to work with multiple versions of Python 3. But this is a Python script. It's the headers are still the same. I just run this on a quick test. I ask for 2 cores, so this is a parallel program. Now the bottom part, instead of bash, this is Python code. So in this case, I import the OS module and I run the MPI run, which we don't have. This should actually be srun, but okay. It's OS system srun hostname, and this will run hostname on 2 different cores. Now this is completely useless, but you can imagine where there are cases that you do some pre-processing using Python. So then the question, so what you can do is you have this, because this only runs once. So if you, for example, you create a loop, you do some pre-processing, you run a program with Astron, and then you do some pre-processing again because it's a loop. So there are valid cases to use things like Python as a job submission script. In general, I would say try to stay away from it because you have to know what you're doing. But yeah, there are, RCC exists now, well, the HPC exists now for like 15 years. I've seen really crazy things going on. People can be creative. I mean, you have to you do your work, and if things, it's Linux, there's 50 different ways to do one thing. Now, I want to mention this. This has not been integrated in our Open OnDemand, but this is something, the script that we started some time ago. This is a job submission script, the generator. It's because people found it sometimes hard when they just start to create those kind of templates, those job submission scripts. What it does, it's just the same as the job generator in Open OnDemand. It will take some input. It does some syntax checking. And then you can copy that code and submit it to your job. Now, we've never gone where it automatically submits a job through the web script generator. But if you want to look at it, I'm not sure if that link is actually still good. Okay. So if you go to our website and it's on one of the support links, you can see the JavaScript generator. So how does it look? It's basically just a form. On the left, you see there's some fields that you can fill in, like the title of the program, the program that you want to run. If you want to get an email notification when your job starts or when it's finished, by default, you don't get emails, but you can submit this. What account you want to run into, how many cores, how many nodes, and then it will fill out this template based on your input. So this is relatively straightforward, but it's like a template that you can copy and paste and create a real job from. Now, I think we still are thinking of incorporating this in OOD. I'm looking at the author of the script, and I think we still want to, right? Yeah. Yeah, so that's still on our plan too. But now you can go to our website and just play around with it, because it will show you all this as batch flags that you otherwise have to look up. It's interesting that it does open API 2.1. But this is an old screenshot, so this may not be accurate anymore. So now comes the collection with random blurbs, because this was the kind of the relatively easy part. There's a lot more complicated. You might notice the moment you start working with job schedulers, it can get very hairy at one point. And one of them is memory. Memory is always a tricky part when you're running with multi-processor jobs. So by default, if you allocate one core, you get 4 gigabytes. That's the kind of the default. Sometimes you want more memory. Your program needs more memory. Now, if you only need one, if it's a sequential program, you need more memory, it's easy. You can use the --mem. It will, under the hood, what Slurm does, it will say each core is 4 gigabytes. If you ask for 5 gigabytes, it will reserve 2 cores. You only get access to 1 core, but internally it will allocate 2 cores. So that you have to take that in mind, because if you have only 16 cores, if your professor only bought 16 cores, and you ask for so if you ask for 40 gigabytes and 40 gigabytes, 2 jobs, they will not run at the same time, for the simple reason because each 40 gig is request 10 cores. So the 2 jobs ask for 20 cores. Even though you only ask for 1 core, it will request 10 cores each. So you'll go over that 16 core limit. Now, this is a very simple example, but we've seen in the past that because people ask for more memory than that partition allows to, their job will not run. And especially if there's go over the 64 gigabytes, this is kind of a magical threshold. A lot of the general access nodes only have 64 gigabytes. Now, there's still a little bit for the operating system, But if you ask for 64 gigabytes, you will not be able to run on those nodes. And there's only a small amount of nodes left that you can run on. If you change that to 63 gigabytes, and I showed the professor, she changed from 64 to 63, her wait time went from 5 days to 1 minute. Because suddenly there's a lot of nodes available that she can run on. So you have to really think if you really need all that memory, especially if you're on in the free resources. And memory limit is enforced. If you ask for 5 gigabytes and your program uses 8, at one point Slurm will say no. It will kill the job. And if you're lucky, it will just get a nice warning. It says memory exceeded. If you're unlucky, you'll get 50,000 warnings errors from MPI, because MPI, one process gets killed, everyone else cannot communicate with that one process anymore, and says there's something wrong with your InfiniBand. You probably all have seen errors like InfiniBand retry, recount, blah blah, and that just it's all red herrings, because it's one process that dies. So memory can be very tricky. If you need more than 4 gigabytes, then you can just use -mem. If you have a parallel program that uses more, there's a mem per CPU. But you have to be very careful how to use that. So if you ever run into memory issues, just ask us. We will try to help you, even though we sometimes also don't really know what's going on under it. But memory can be very tricky with MPI, or with Slurm. But in general, if you have just a sequential program, use --mem and ask for more memory. And that brings me to this one. A lot of the time the question is, why is my job not running? Now, there's 50,000 different reasons why it cannot run or will not run. It's because you may have asked too many cores. Your professor may have only bought 100 cores, so you ask for 150. What also is possible, you share your cores with your colleagues. If you're in a lab and everyone asks for 50 cores, that 100 core assignments suddenly is full. And like I said, you may ask for too much memory, and you may have to you have to wait for those 2 or those 10 or 100 of whatever large memory nodes. So there's a few things you can look at. You can see the SQ-me that shows you all your commands. If there's sometimes it gives a reason why it's not running. You can use the --start, which I should have put here, to show the start time, because maybe you're just too impatient and your job might start in a day. This is just SSQ-me, shows you and there should not be a space in there. The -q-a, my account, shows you everything that's in your account. So if you're part of the Beerly group and you want to see all the partitions that are in the Beerly queue, you say -a Beerly_q and you show everything that's in there, which will probably be the professor himself. That's or it's just, if you want to see a lot of details about your job, you can do control show job in your job ID, and it will give you a lot of information. If it's running, where it's running, how much time is left. Now, I mentioned this before. This is one of these topics I usually when there's a lot of, let me stop for a second. Are there any questions up till now? So this is one of these topics. This is actually a collection of topics that I go through when there's still time left. So software. I mentioned that we have a lot of software on our system. On our website, the software, you can see a whole list of versions. If there's anything missing, just ask us. We'll be happy to install it for you or help you install it in your home directory or on our central system. Of course, you can also just download it yourself and compile it yourself. And if you run into issues, we may help you with that too. So because we try to have all these versions available, you don't want to have everything in your path by default, because we want to have multiple versions. There's different versions of the GNU compiler, PGI compiler not so much. If there's multiple versions of Python, R, etc. So how do you get them in your path? So that's when we use the module system. the modules is an easy way to get programs in your path. So if you want to get GNU version 2.1, we don't have 3.1 anymore, but imagine you want to have an older version in your path. You can do module load and then OpenMPI. Now, OpenMPI is available in multiple versions, but also for all the different compilers. So I think we have like 10 different versions of OpenMPI. So that's why we have modules. Modules is if you want to see what's available, you type the command module avail. Module avail gives you a lot of the list of everything that's available. Now it's hierarchical. Like I said, we have different compilers. So if you know you want to use the GNU compiler, you do modulo GNU. And then when you type module avail again, you'll suddenly see more packages that are specific for GNU. Now you want to have MPI because you don't really want to use MVA pitch. So you use module load OpenMPI. You can combine it into one, but you can also do separate. And suddenly you do module avail and you see more packages that are specific for GNU OpenMPI. If you want to run a specific version, for example, you want to run the, I'm not even sure that's the latest anymore, but if you want to do this experimental 11.2 GNU GCC, you do module load GNU and then the version number. 4.1 is the default now. It wasn't when I created this slide, but if you want to run this specific version of OpenMPI, do module load OpenMPI. So if you run these two commands, you'll get the specific OpenMPI for that specific version of GCC. So there's a lot of options available. Now the question is always, why do we have all these versions? Well, we have someone who runs OpenMPI 2.1 because there was a bug in OpenMPI at that time that he uses for his application. And because it was fixed in later versions, his application stopped running. I'm not going to ask for the reason. If we can help him fix it, sure. But in this case, we just have OpenMPI 2.1. It's sometimes we know that the version 4 is stable and there may be an experimental version OpenMPI 5. We don't want everyone to put on the experimental version 5, but for that one student that really needs it, we make it available. So that's why you can have multiple versions. But if you log in and you just do module avail, you'll see all the packages that are available. And then if you do things like load GNU, you'll get more packages. And I think the command that I haven't shown here, module spider, actually searches that hierarchy tree to show what's available. Now, I used to have this in the beginning of the slides. Does everyone here have an account on the RCC? And now I'm going to skip. So now you have an account, and probably everyone here already knows these steps. You work with a professor, and the professor says, you should run on my resources. What you do then, he can add you to his resource, but what you can do is you log into our website. If you go to rcc.fsu.edu, somewhere on the bottom is in the middle, there's a manage my account. You log in, and then there's a list account groups and HPC partitions. Click on HPC partitions. You get a whole list, and there's a really long list of all different accounts. I still call it partition, but it's called an account. Now, for example, I work with Dr. Una Krishnan, and he gives a class, and I want to access his course. So I see that I pick it from the list. There's more information on there. I can see also what's available. So he has a total of 900 CPUs. He's a very intensive, compute intense user, a professor. So I click on it. I see all the information. On the bottom, I see groups. I click on that and I say request enrollment. And it says, hello, I'm Paul. I want to access your machines. I submit a request. The professor gets an email saying you want to approve this student. So in that case, he will say yes or no. Hopefully he will say yes. And I will get an email that I have been enrolled in his resources. So if you ever need access to a partition of an account, it's all self-serve. So you can send us a request, but in general, we want the professor to approve the students. So this is a whole self-serve to make it easier for our users. Now, of course, the professor at the end of the semester can go in and say, oh, Paul, he dropped out of my class. I just remove him. So that can also happen. But so this is kind of a more advanced topics. There's a few more coming. There's just that's why I say random tidbits here. So job arrays. A job array is a very efficient way of having a lot of the same job. That sounds kind of confusing, but imagine that you do a lot of analysis on little small files and all the job submission scripts are the same. It's just one little thing. If you divide up if for example, you have an embarrassingly parallel program, you can use MPI or you can divide it up and say 100 different steps. A job array, you can submit 100 different sequential jobs that will only do that one little bit. So why is it sometimes faster to have a job array instead of a parallel thing? It's because they're all independent. They run independent. So you can submit 100 small jobs. They might not run all at the same time, but especially if you do it in combination with one of the backfill partitions, you can run very efficiently the 100 different steps. Remember, if you submit a job for 100 cores, it might take a while before it starts. But those 100 individual job array steps, they may run almost immediately because they may be very small. Now, of course, your job has to fit that paradigm. But if it's all very small, little, it's the same script. If the script is the same, it just depends on one thing. Just the only difference between all these runs is this variable slum array task ID, which is different for all little steps. So if you can break up your program in a number of small steps, Slurm is very efficient with job arrays. I'm not sure but if you, for example, can break it up in 5,000 steps, you can just submit job array. You just submit one job, which breaks up in the job array of 5,000, and it will just be very efficient because it's all very small jobs. Slurm likes small jobs, so you might be a lot faster than just doing this as a parallel program. So this is kind of something to keep in mind. If you know your work and you know that can fit in a lot of small steps, this is the way to go forward. So now you need help. The first thing you can do, except for looking things up online, is to submit a request to support at rcc.fsu.edu. It's nowadays we've switched to our to FSU's new ticketing system, Salesforce, which we all really love. But it's horrible. But anyway, the way to access it is still you send an email to support@rcc.fsu.edu. There's a few things that you can do to help us help you. We would be happy to help you, but if you can help us a little bit, that makes things a lot faster. So make sure to say, this is my job script. I run this script. And tell us a little bit about output files. Don't say it doesn't run. It's just that's not much you can help. If we can look at your output files, we can actually spot things that you may have missed because we see a lot of these errors. If you see an error, just tell it what it was. There may be something, my job is not running or my job crashed while it used to run. And then there's a little line that says quota exceeded. It's always nice to kind of see that in advance. If possible, if you have a job ID, include that. So we can probably look it up, but it always helps a little bit if you have a lot of jobs running, that we know exactly what went wrong. Because sometimes there's an error on our side. Sometimes the machine is flaky. Maybe something is wrong on that one machine. And if you have 10 jobs and one fails, mysteriously fails, we can actually maybe pinpoint the machine. So try to be precise and give as much information as possible. Now, this is really the last slide. That's kind of if there's still time, which is job dependencies. Sometimes you have multiple jobs that depend on the outcome of the other. So if you have multiple steps in your workflow, but you don't want to submit them as one large job, so you can break them up in different steps, but you want to make sure that they run after each other. So that's why you have a job dependency. So if you say this job can only start when this job finishes, you can program that and you say And the only thing is that you have to enter the job ID in this case. So in this case, I submit a job, it gets processed, it gets job ID 1, 2, 3, 4. And in the next script, I just say only run after 1, 2, 3, 4. There are ways to get around this, but then you have to do more advanced job description. But this will basically make sure that jobs run independent of each other. There's also other options. For example, you could submit if what some people do in the backfill too, which is like a kind of they submit a script 20 times, but they only want run to run. They give it a name, and then they say dependency singleton, and they have the job name. All jobs with the same name, Slurm will only run one of them. So if I call my job Earth model, and I submit 20 of them with that job dependency, it will only run one. Now, when one finishes, it will start the next. When that finishes, start the next. So it's kind of only run once one with that name. And for example, if you use the backfill queue, the backfill 2 queue, you can use that to submit to make sure that there's always a job waiting for you of running. And I think that's the end of my. Does anyone here know what a MPI space, what a shared MPI space is? Then I'll just leave it up here, but I'll open for questions. Okay. So let me repeat the question for people, or what people online can see this, of course, too. Yeah. So no, there's no guarantee that the job runs that all the 100 jobs tabs run at the same time, and that's a good thing because it gives you a lot more flexibility over just submitting 100 core job. Is there any warning that will end up exceeding times? So you should see a job array as one job, but also as 100 different jobs. So if you submit it to the backfill and there's 4 hours wall time, every of that jobs tab have 4 hours. It's not that if one starts, that the last one has to finish within that 4 hours. So they will all have 4 hours. So it may be that 90 will start immediately, finish, but the last 10 will maybe have to wait for 8 hours because someone else submitted the same large job. So no, the individual jobs tab has the same, they all have the same wall time limit. I hope that answers your question, Jonathan. If there are any other questions, then I say thank you. Okay.
Yeah.
And I would say stay tuned because what's our next, let me show up. What's our next workshop? Okay, so not next semester, we'll have more multiple workshops. We'll have one on Open On Demand, which I mentioned before we go deeper into Open On Demand. We will have, we'll have a workshop on R. So if you're interested in R, and it will probably be done through Open On Demand, so make sure that you're tuned in. And we're going to give another Python boot camp. So if you haven't seen our last one, we'll take our roadshow to the education building, but I have a really nice room. We will also do online, but really, if you want to learn our Python, join us in our work in our boot camp in March, I believe. Yeah, in March. Thank you.